Swayam Prabha. Digital India. Educated India.
Today we will talk about it in details. We introduced it, now we shall see we will resume, we start from where we stopped. So, as I said, a formal system has got a few features. Once again, so the features are the following, and the essential feature of one of the essential features of a formal system is it will have signs like A, B, C, and it will have constants, it will have variables like x, y, z. Very importantly, what makes a formal system is its rules, the formation rules that allow only grammatical strings and rules that prohibit ungrammatical strings. We started with the formal system that can produce the following strings. As I said, either we have the standalone WFF, standalone sign A or B or AB or BA or AB, 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 whatever. So, as I said, the string alternates A and B, it alternates with A and B, that is it will never have two successive or three successive occurrences of A or B, but it can have different occurrences of A and B in any order, but never will A or B repeat itself. That was what we desired when we started talking about it, and we gave an algorithm for generating such strings. So, now we shall see how actually the system works. So, the fourth feature of a formal system I mentioned was recursion, that almost every formal system is recursive. Recursion is the very key to any formal system. What is recursion? After we understand recursion, we can understand how the formal system works. Recursion is basically this: a system is recursive when it can be described in terms of a base case and when the n plus 1th case is derived from the nth case by using the rules of the system. So, now we shall see how recursion works. We get back to the rules of the system and we will see how it works. So, what is our we said there are two main things, right? One, the base step of the recursion, and two, the recursive steps. Now, what are the base steps of our recursion? Already it says that it is the 0th step. Already it says that A is a well formed formula. So, it can either be A, then it says B is a well formed formula, B, these are all starting points, or AB or BA. Now, notice we are not supposed to make these strings, they are already there, they are provided, the rules declare that these are given, you cannot make them up, they are axiomatic. Now, we introduce another very important idea for a formal system, the axiomatic elements or the axioms. An axiom is something which some idea, something which is foundational and which cannot be created, which cannot be made, an axiom cannot be made. So, it is foundational, and every other thing is made up of axioms. So, the axioms are the very foundation for any system, and axioms, as I said, are simple, they cannot be made, they are basic. If you do not have axioms, you do not know, because you need some step for the very beginning of a system. The rules must be applied somewhere. If there is nothing, I cannot do anything. So, just the stepping stone, the first stepping stone I require. In this case, that is the axioms in every formal system. So, you can remember the Euclidean axioms. So, some of those he calls postulates, and some of those are axioms. So, all those are sort of, those are not theorems, because those could not be proven by using any other thing. Those would be, so axioms are self evident, in the sense axioms are given. Here that sense of self evidence is not really there, means there is nothing like, there is nothing very convincing in A, just A is given. So, here one thing, one feature makes all these things axiomatic, all these strings like A, B, B, A, that is the givenness of it. That is the fact that you, by using this system, cannot make A or B or AB or BA, they are already there. In that sense, they are foundational, they are basic, and they are axiomatic. Now, then the first formative rule, if XA is a WFF, then XAB is a WFF. If XB is a WFF, then XBA is a WFF. These rules will help us create new WFFs. Now, the point is, suppose we have a task, let us make a string like B, A, B, A, B. How to make it? That is the question. Now, let us concentrate on the first two signs of it, B, A, that is the starting point, and then by using something we can make B, A, B, step by step procedure, then we can make B, A, B, A, then we can make finally B, A, B, A, B. So, these are the steps for doing it. Now, the strategy is this, we first consider the first two signs of it. Now, I can expand it this way, in the first step I can go till B, A, B. How do I do that? Now, you see, it says that the rule number 5 says, so for me the first two letters are B, A. Now, you see rule 5, if XA is a WFF, then XAB is a WFF. Anything could replace this, but our purpose will not be served if we just replace X by anything, because we need BAB, right. So, what I do is I replace X in rule 5 by B. What I get? I rewrite rule 5 by replacing X by B. I get if XA is a WFF, I am not writing is a WFF, it will mean that, then XAB is a WFF. So, when I replace X by B, I get B, if BA is a WFF, then BAB is a WFF, and then already we know, now I can derive BAB only when I have both BA and this rule. I have BA here. Once again, look at the modus ponens idea, that is, in order to have beta, from alpha implies beta and alpha, I need, sorry, in order to derive beta from alpha implies beta, I need alpha. Now, here in order to derive BAB from if BA is a WFF, then BAB is a WFF, I need BA, and already it is there, already BA is a WFF, I know. So, I know BA is a WFF. So, now we apply rule 8, which says if W2 is a WFF can be derived. So, this says that, sorry, this says that W2 is a WFF can be derived from WFF, from the WFF W1 is a WFF and the WFF, if W1 is a WFF, then W2 is a WFF. W1, W2, these are any strings of A and B. Now in our case these can't be any strings, now they are specific in this context. So for us W1 stands for BA and W2 stands for BAB. So we know that BA is a WFF. We know that because rule 4 tells us that BA is a WFF, and by replacing X by B already we have made in rule 5 already we have made if BA is a WFF then BAB is a WFF. From that we can easily derive that therefore BAB is a WFF. So this is the very first step of it. We have not reached BA, BAB, we still need other things. Now you see that we have already got, now we have established that BAB is a WFF. Now BAB has been added to the list of WFFs. Then we can go to the next level. We once again, now what are the letters B, A and B? The last letter is B. Now we can replace X by BA in rule 6, and by doing that rule 6 will give me, I just erase the rest of it so that we can make some space and we can do it. We will once again use the formation rules here. We will now apply the formation rules on the string BAB and we shall see what happens. So the last is B and then I want to expand, so I have got XB, so then I can replace X by BA because already BA is now given, right, already BA has been produced. So what do? I just write if BAB is a WFF then BABA is a WFF. So that I do by using rule 6, not rule 5. In the previous step we used rule 5, now we are using rule 6, and by doing that, so already I have BAB and I am by using rule 6 I get if BAB is a WFF then BABA is a WFF. I combine the two, I do mode disponents once again. I don't require this therefore because already therefore is there, it has established whatever it tried to establish. Now we have BAB is a WFF, and if BAB is a WFF then so is BABA. By combining the two, by applying implication, the rule of implication, I derive BABA. So I'm here now. So this is my step 1, this is my step 2. Remember step 0 was given, step 0 was actually this thing, then this is step 0 in this case, and then in step 1 we derived BAB. Now we have derived BABA in step 2. Now we have established BABA. Now our last letter is A, so we will once again use 5. So actually we'll alternate between rule 5 and rule 6 to make a string like this. Now we understand that, so by using that I just conclude what I said. By using that already we have established that BABA is a WFF, this is a WFF, and then after applying rule 5 and after replacing X by BAB I get if BABA is a WFF then so is BABAB, and I derive BABAB. This is the final thing I wanted. So at step 3, this is 0, 1, 2, 3. At step 3, this is step 3 of recursion. In the third recursive step I derive my desired string, which is actually BABAB. Now, one thing we understand that we can generate a string that is desired, but the point is, how does it prohibit the generation of a string like A, B? That we'll see how it actually prohibits it. Now, the problem is, I can write, if I just want to make some space and I erase some of it, and we'll see how this can be derived. Okay, so we are ready now. The point is, we'll see how AAB is banned in a sense. How do I make it? Nobody stops me from replacing X by AA. I can make, so I can use rule 6 and I can replace X by AA. What do I get? Easily I can get if, by replacing X by AA, if AAB is AWFF, then AABA is AWFF. So the point is, we have seen how we can generate a desired string, but we haven't seen how we can stop the system from generating an undesired string, like say for example AAB. So now we shall see that. In order to produce AAB, we remember that we need to look at the first two letters, AA. We start there. So I can very easily replace X by A to make AA. So what is the rule I use? I use rule 5, and I can easily write, so you call it rule 5, rule 5 prime. You can see that I just write in a short form. I'm not writing the entire rule. I can write, if AA is a WFF, so is AAB. Not that this is banned, I can easily do it. But the problem is, this step is fine. So I can use rule 5 for doing this. But in order to derive AAB, I need AA as a given string. Unfortunately, or fortunately actually, AA is not given to me. Look at the list of my given things. I have A, B, AB, BA. I don't have AA in the list of the given things. So there is no way I could derive AAB. This is how. Now look at the power. Look at how powerful this very small algorithm is. It resists all such things. If it is not clear, let me just add another step to it. For example, how to stop the generation of a string, once again, like BBB. So let us take something new, BBB. I don't want BBB. How does the system stop this thing? How does the system prohibit BBB? Look at the first letters once again, B and B. So I apply rule number 6. I just replace X by B. I once again write in a short form. Let us call it rule 6 prime. Sorry, not double prime. Rule 6 prime. And it will look like, we want to stop BBB. It will look like BB. If BB is a WFF, so is BBA. Now you see, you cannot even make BBB here. So BBB as a string is in a sense prohibited even at the level of rule 6 or rule 5, at the level of the implication rule. So in the previous example, we saw that we could format, at least we could form AAB. If AA is a WFF, then so is AAB. This was not blocked, but we can see that you cannot even have something with 3 successive occurrences of one letter, because even at the level of the implication rule, it is blocked. So you don't even have to look for something given in order to block or construct something. The rule itself does not allow you. The implication rules themselves do not allow you to make anything like BBB. So that is how it blocks the generation of strings like B, 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 or A, B, or for example A, B, B. Once again you can see that for A, B, B it is not possible, because you once again apply rule 6. You get, if AB is a WFF, if AB is a WFF, so is ABA. So ABA, it doesn't, once again it is blocked at the implication rule level, that is at the level of rule 5, rule 6. You don't go to the next level, but had it been ABB, you could have gone to the next level somehow, because you could at least make something like if AB is a WFF, I'm sorry, if AB is a WFF, so is, if AB is a WFF, so is ABB, by using rule 6. You could have done that, but then you would not find, I'm sorry, you cannot, yeah, it is once again stopped at this level. It is once again stopped at this very level, because it alternates. The rule says that if AB is a WFF, then ABA is a WFF. Yes, once again it stops the generation of a string like ABA. So this is how we can see that it generates only the desired strings, and it blocks all the undesired strings. You have to follow rules for doing that. I was looking at the rules, I was using them so that we understand how the formal system works. So this is the very idea. And how is it recursive? You see, recursion, as I said, is defined in terms of the given. In our case, the given are these things. The given are A, B, AB and BA. So these are the 0 steps, and then the recursive step. At every level we saw that, see, at this level, at the level of step 3, we have used something that was generated in step 2. This is what I said when I said that at the n+1th level you use the nth level, that is, you define the n+1th step in terms of the nth step. This is the heart of recursion, that the n+1th step. So once again I repeat, for at the third level, we, in order to generate BA, BAB, we had to have BABA, which was generated in the previous step. So you cannot skip a step, it is not random. You have to go in a systematic way. You use one rule and then you generate one string. At the next level you work on that string and you come up with the next string. So this is how it goes on. So that's why we say that recursion is defined in terms of 0 step and the n+1th step, which is formed, which is built on the basis of the nth step. So we can see that here. So after that we go to the next topic. We have seen so far what could the very word formal mean. We try to discuss a formal system. So here we start. He comes up with a system that is called sigma f in his syntactic structures, which was published in 1957. We shall see the grammar of it. It starts with a sentence. Now what is sigma? Sigma is the 0 step, as we said. Remember, in the case of succession we had 0, then the successor of 0, which is 1, then the successor of 0, which is 2, then three, and so on. And every time 3 is built on the basis of 2 in that sense. So 3 is there because 2 is there, 2 is there because 1 is there. This is the dependence of recursion. So you have to have a base step and then you derive things. Similarly, in the Chomsky grammar, the base step is defined. What is the base step? It is sentence. We'll not understand just by looking at these rules, but these are starting points. And what is F? F is actually a set of rules for rewriting this string called sentence. We'll see what it actually means. So let us first just see the strings. Sentence, so how to read it? We just say sentence goes to NP plus VP. VP goes to verb and NP. NP goes to NP sing, which means singular, or NP plural. NP singular goes to T plus N plus null set. That is empty. That is nothing basically. And then NP plural goes to T plus N plus S. Then we'll talk about all these things, but let us see how it works, and very importantly what this thing means. This right arrow has got a very simple meaning. When you find something like X goes to Y, it has to be interpreted as X is to be rewritten as Y. So following this, when you look at this rule, sentence goes to NP VP, you just write it this way. You start with sentence, and then I rewrite in the next step. I rewrite sentence as NP plus VP. This is compulsory because I have no other route. Now NP can be constructed in two different ways. Either, now this thing tells me that I have to choose one and only one thing from the brace, right? So the brace, it's very important. The brackets are very important. I'll talk about that. This bracket tells us that you have to take exactly one thing from this bracket, but you have to take exactly one thing, not that you can skip that thing. So either I take NP sing. So suppose I want to take NP sing, then how do I, so I rewrite NP as NP sing, and then how do I rewrite VP? I take I don't have any other option. VP goes to verb and NP. I rewrite verb plus NP, and then I once again want to rewrite this NP. I once again write NP sing, that is singular, verb plus NP singular, and then NP singular has to be this rule. Once again, there is no option for me, that is T plus N plus nothing. So this is basically nothing. I just write T plus N plus nothing plus verb plus once again T plus N plus nothing. That's much we can derive. Then what is a verb? Now we can see that a verb is aux plus V. We get back to the old format, and I rewrite this line T plus N plus nothing plus AUX plus V plus once again T plus N plus nothing. Now this is once again compulsory. I couldn't have done anything else here. Verb goes to aux plus V. But what is aux? This is very interesting. Now look at these brackets. Here C has got no bracket, which means this is compulsory. This is mandatory. I have to take C anyway. After that, these are in brackets, but these brackets, unlike the brace, tells me that they're optional. So this bracket is optional. So I can either take this, I may or may not take this. Then I may take this also, but also this bracket basically tells me two things. That is, it tells that first, it tells you that I'm optional, and also it tells you that if you take me, then take in the given order. What does it mean? That is, if I want to choose, the second element, I cannot skip the first element. I have to choose them in order. So I want to choose, for example, C, then have plus N plus B plus ing. I cannot skip this. I can skip the third one. So I have to go in this order if I want to go at all, but I cannot go from here to there. That is banned. Not that I have to take this, as I said, they're optional, but if I want to take the third one, that is, if I want to take this, then I have to take this. This is the point. So I choose, for example, I take the first one. I take just C in the old form. So I, instead of ox, I rewrite ox as C. What is my derivation now? T plus N plus nothing plus C plus V plus T plus N plus nothing. This is my next thing, and then I need to see what these things are. T means only one thing, that is V. N maybe is a man or ball or whatever, and V can either be hit or take or walk or read, whatever. Now I get back, I choose this. T has to be Z, and N, I rewrite N as, now once again this is optional, I rewrite N as man, and C, what is my C? C is either nothing in the context when NP is plural, C is S when the context is NP singular, or it is past. We get back. So I choose now because this is singular, this is NP sing, because this is the context, the context is singular, it becomes this becomes S. Once again, look at the rule. S in the context NP singular, nothing in the context NP plural or past. You remember that the brace is, the brace tells that I'm not optional. You have to take at least one, you have to take one thing from me, not at least, you have to take exactly one thing from me. You cannot skip me, but you cannot take more than one things, but you have to take one. So and the context is also given. So I can either take past or S or nothing. Now the nothing and S are context sensitive, which means that they depend on the context. In the context of NP singular, I can take S. In the context NP plural, I can take nothing. I can't help it because it is NP singular, I can see that. So I have to take S, and then V, I can take any V, they have given a few. I take, for example, hit. What do I get? I get hit, and then once again T goes to Z because T has got only one meaning, and N, I choose ball, and once again it is nothing. I come here. This is pretty much towards the end of it. Then there is something else. I have to combine now these strings. The combination is also sort of rule governed. So man, there is a rule which says that man plus nothing makes man. There is a rule that says that S plus het makes hets. Now I'll talk about this, but just let us see roughly what is coming up. So nothing means nothing, ball plus nothing makes only ball. So roughly it is this sentence, the man hits the ball. The man hits the ball is a perfectly grammatical sentence we have created, we have generated by following rules that are given in a few steps, in 7 steps, but this is not the end of it, because Chomsky's intention is actually to come up with the very physical sentence, that is the something with physical speech sounds, the man hits the ball. How to do that? So that's the reason Chomsky has designed rules of two types: the phrase structure rules and the morphophonemic rules. We can see that there are rules of two types. We start with the second type. These are the terminal rules. What do I mean by that? These rules concern the end product. So what is the end product? It's a sequence made up of physical sounds of English. So how do they look like? It looks like something like this. You can see that these are the terminal rules. Now we differentiate between a word and its physical manifestation. The word the or whatever, say man, it's an abstract thing because no two people say man in the same way, but the word man is manifested through 2 or 3 or 4 or 5 or infinite different manifestations or infinite different pronunciations. That physical pronunciation is something we can hear, but we do not hear the word man. So this is one very important thing. Words are abstract things, but their realizations are different, their pronunciations are different. Now this is the pronunciation of the word man. The word is man, which is here, but its pronunciation, its physical counterpart is this. This is the terminal thing. This is my end product in a chain. Also het. Het, this is a word, but its pronunciation consists of physical speech sounds which are to be produced by using the organs of speech. Once again you see that at the word level, at the abstract level, het and s unite to make hets. In hets you can see both, but not that everywhere you can see both. For example, the third singular s, or for example take the plural, English plural. You take something like sheep plus the plural s. You want to say 5 sheep. You don't say 5 ships. You see that s in sheep, the final product, you don't find this thing. You don't find this plural s. What does it mean? It means that the parts need not be presented, need not be physically presented in the final product. The parts will play the role, but then they may disappear, or they may change the shapes, or they may appear the way they are. For example, the plural s is present in a formation like pens. That's fine. You don't write it this way. You write it, the physical word will be something like this, because this is the pens, but it is not there in men. There is no s in men, but you can understand that the abstract s is there in men. Or for example, you say 5 pieces of furniture, right? Here the sense of plural is there, but you don't say furnitures because that is not allowed, or sheeps, that is not allowed. So the plural s is pretty much there because you are saying 5. I saw 5 sheep, but at the same time it is not physically there. That's the difference between a word and its physical manifestation. In the word pens, it is physically there. The word English plural, the word that is the English plural morpheme s. In men, it has changed its form. You cannot find any sa or za. And in a word like sheep, it just disappeared, right? So the physical, the abstract word is not the physical manifestation of it. So the physical manifestation is a terminal thing. Chomsky's intention to come up with rules that will also yield the final products like man, this thing, het, or hets, or het in the past formation, or the. All these things are the terminal things. Now, rules that concern the terminal products like the, man, het, het are the morphophonemic rules. These are combination rules which have abstract words on the LHS and have real words having speech sounds in the RHS. So, this is the combination of abstract words past and het. This is the past form of het, which is actually het. Now, you see, unlike other past formations, for example, go, past, that makes it went, or past plus want, that makes it wanted. Now, the past in a sense gets manifested in wanted, but in went, well, it is there, but its physical form is nowhere there. This is very, very important, but in het, it is just not there. Het and the past morpheme make het. So, it is completely it has vanished, it has disappeared, it is invisible there in this formation. So, all these terminal things are there in the morphophonemic rules, the combination rules, and other rules will talk about the previous steps that do not concern, that do not apply to the terminal strings. So, these rules are actually phrase structure rules. So, Chomsky talks about rules of 3 types, but we have taken just 2. The transformation rules we will discuss, but not now, maybe after a few sessions. Now, these are all we are using a phrase structure rule to rewrite sentence as NP plus VP. Once again, another phrase structure rule to rewrite NP as NP sing and VP as verb plus NP. These are phrase structure rules because these rules do not concern the terminal strings like man, het or het. They concern non-terminal strings. And finally, the morphophonemic rules will produce the string the man hits the ball. This is our intention. So, by using rules of 2 types, we should be able to make a grammatical sentence like the man hits the ball. Could we make a sentence like man hits the ball? No, because no phrase structure rule allows us to rewrite NP as, there is no rule which says that NP singular is to be rewritten as NS. Had that been there, we could derive something like man hits the ball. Now, can you see that something very similar we did in the old system, something very similar we did when we blocked the derivation of AAB or ABBA. These are blocked, but we wanted structures like AB, AB or BA, BA. These are all fine. We saw something very similar, that somehow the rules do not allow me to do anything like this, and they always allow me to do something like this. Similarly here we can see that nothing allows me to come up with a bad structure like man hits the ball. In English, it is not allowed to use a count noun in its singular form without any article, like I must have either a or the or some or something like that. Without that, I cannot just say man goes. I have to say a man goes, or the man goes, or some man goes, or all men go, or something like that. Or not, men is plural, we are talking about the singular count noun. So, but think of an uncount noun like water. I don't have to say a water, I saw a water. I just say I saw water, because water is not a count noun, but we are talking here, we are talking mostly about the count nouns. Look at Chomsky's list. So the nouns are man and ball, both are count nouns. So we must have either a or the. Here a is not given, so we have something like the. So we can have the man or the ball, we cannot have just man or ball. Those are banned. We can see how rules stop such undesired things and allows only desired things. We shall see how we can make other sentences by using these phrase structure rules. So the next step is this. Now we have to go for T, N and aux, V, T, N and all that stuff. As far as T is concerned, we don't have any other option, because we can see that T goes to just one thing, the. We get back, we just write the. And for noun, we have many options, man, ball, etc. We choose man. Aux is a very interesting thing here, the aux rule mainly. We'll notice here that aux goes to C, have plus N, B plus ing. This bracket is actually a very interesting one. It tells us the following. It tells us that C is not bracketed, so C is kind of compulsory. So I have to rewrite aux as C anyway. After that, the selection of this one or 2 is optional, which means that I may or may not take have plus N, and I may or may not take B plus N. But this bracket means that if I take both, not that I have to, but if I take both, then I have to maintain this order. That is, I can either go for this combination. I can either say that aux means auxiliary, basically it goes to C has to be there, remember, and then it is B plus ing. This is fine. I also could have done, so this is fine, or I could have done aux goes to C, have plus N. Also I could have taken both. I could have made this rule, aux goes to C plus have N plus B plus ing. But the point is, one meaning of this bracket is, if I choose both, that is have N and B plus ing, I have to maintain this order. That is, this is 1, this is 2. What is banned is this. If I choose both, I cannot have this combination. This is not allowed. So the brackets mainly tells us then a few things. One, that it is optional, and two, that if you select both, then maintain the order. So depending on my selection, depending on my choice, I do something. So we get back to the original page, and I choose C, nothing else. And say for V, I choose, V can be hit or take or walk or read. I choose hit. Plus T, I don't have any option, T goes to the. N, I choose ball. I could have done something else, theta. So it's pretty close to the end of the sentence, but it's not the end of it. At this level, I would like to distinguish between a word and its physical form. Why this is important? This is important for the following reason. A word is an abstract thing, but its physical representation, its realization is different. It gets manifested, realized through speech sounds. Sometimes it gets realized through nothing. For example, we may consider the English plural S. So the S that makes pen, pens. But the same S makes man, men. So in the grammatical rules, it is not true that when X and Y combine, when X and Y get combined, you get XY in the physical format. In the physical form, X and Y come together, but the realization may be of many different forms. For example, here, if you add this plural morpheme S to sheep, you once again get sheep, not sheeps. What does it mean? It means that the morpheme added may or may not be physically manifested in a similar way. For example, with pen it does, but with men it doesn't, with sheep it doesn't. But from the context we understand that in all three cases actually the S is present. In one it appears very clearly, in the second it doesn't appear, it has changed the form, and the third it has completely disappeared. What does it signify? This signifies that words are abstract things, and when they get realized they are different. They may also disappear when they get realized in the physical speech. So we take this thing and we take this lesson and we try to see the rest of it. Now we can notice here rule 12 through 19. These rules are called morphophonemic rules. Why they call morphophonemic? Because they concern the end product. They apply to the last thing, the last part of the string. The last part is actually this physical speech sound. So at an abstract level, I get a sequence like 6, which is actually the, man, nothing, plus C, plus head, plus the, ball, plus nothing. But this is an abstract sentence which has to be realized. So the realization rules are called the morphophonemic rules. They combine man and nothing and make something like man. Now that a comes is represented rather like this, and C, you remember that C, we just go to the rule. C is nothing in the context NP plural. When you have NP plural with C, it is nothing. It becomes S when it is in the context NP singular, and in the past, past is not contextual. So the past morpheme which gets realized as, say, something like wanted. So in that you can see that past plus want becomes wanted here. This is the past. Now this past is not context, it doesn't depend on any context, it doesn't depend on plural or singular, because the English language doesn't, as far as the past context is concerned, it does not distinguish between singular and plural. So we get back to the string, and here I get this is the physical manifestation of the, which looks like this. So I just write this. I get the man, and because this is nothing, it looks like this, the man, and this C becomes S, and het plus S. I should write actually the word, not this form. So the word is this, het plus S becomes het. Now this is not really the word, but this is the physical manifestation of the word hits, and then the ball remain the ball, and this is nothing. So practically this string, if you could teach a computer how to pronounce these things, then, and also if you could teach the computer other rules, it will process this sentence, it will rewrite this, in a sense it will rewrite all the things, all the strings, and derive through those rewriting rules, it will derive actually this physical thing, that is the man hits the ball. We are right now studying two types of rules, the morphophonemic rules, which we have already seen, and the phrase structure rules. That's it. So we have seen how a grammatical string has been produced by doing this exercise. But now I would like to draw your attention to another thing. We must notice, all of us must notice, that there is something, there is a feature, there is a common feature. There is a feature that is shared by both the formal systems and Chomsky's system, which is a formal system of course, but this is a syntactic system. What is that feature? The feature is something like this. It allows grammatical sentences, we have seen, like it allowed strings like A, B, or strings like B, A, but it blocked strings like B, A. We have seen how these were blocked. Similarly, here also ungrammatical strings will be blocked. How? We can see that very roughly. Suppose, think of an ungrammatical strings like man hits the ball. This is ungrammatical because this is a count noun and a singular count noun, which means it requires an article, either a or the or something, but it doesn't have that, which is not allowed in the English language. So what shall we do? We shall see that this structure is not even allowed by these rules. How? It is because the first step is the sentence goes to NP-VP, that's fine, and NP goes to NP singular, that also is fine, but then NP singular goes to T plus N plus nothing. Now here you see that T is mandatory, you have to have the T, and that because you have to have T here, T will be manifested into the, so you cannot skip the anyway, so you end up having the. You will never make a string like your NP will never be man or ball, so you cannot construct a sentence like man hits ball, that is impossible. So this is how it in a sense blocks the ungrammatical sentences and allows only grammatical sentences. So we have seen how Chomsky made syntax a formal discipline, and we now understand the meaning of the word formal. Thank you.